All right, Algebra 2, Lesson 45, finding the line of best fit. Finding the line of best fit is going to be based upon the idea that we're going to be looking at data in a graph, and sometimes that data is all over the place a little bit. It's kind of like a scatter plot. So there may not be a linear line that represents that data. At least it won't look like a line. But there might be a line that fits it in general. Does that make sense? So a line that's basically the average of that data. Okay, so regression is the process of identifying a relationship between two variables. Now, sometimes two variables are directly related to each other. Okay, for instance, temperature to swimming trunks, right? As the temperature goes up, the number of swimming trunks does what? You think as it gets warmer outside, there are fewer and fewer swimming trunks that people are wearing? All right, so there's a direct variation between the temperature and swimming trunks, right? So as one goes up, so does the other one in terms of number of people wearing swimming trunks or flip-flops or different types of summer type apparel. And the colder it gets, right, as the temperature drops, so doesn't the number of flip-flops and swimming trunks, right? Okay? You could look at it now. Where we would see maybe an inverse relationship to temperature would be as we see the temperature go up, we might see, let's say, winter coats, right? As the temperature goes up, what's going to happen to the number of winter coats that people are wearing? It's going to go down, right? So there's an inverse relationship, and as the temperature drops, right, we see the number of winter coats go up, right? So do we see things that they do have a relationship though, right? Do we see that there's a relationship between those things? One just might be direct and one might be inverse. Does this make sense so far? All right, but we could look at things and say that there's no relationship to those things at all, right? Have you ever heard somebody use or talk about something and somebody says, what does that have to do with the price of tea in China? No? All right. Okay, because whatever we're talking about probably doesn't affect the price of tea in China at all, right? Because there's probably very little that we do here that affects the price of tea in China. So it's like saying, I don't know, I'm trying to think of things that affect, let's say, the number of earthquakes in California and the price of tea in China. Do you think that those two things have any relationship to each other? No, right? They're disconnected from each other. So if we looked at the number of earthquakes in California and the relationship that it had to the price of tea in China, we might see that it's a scatter plot because there's no relationship to those two things, right? Okay? So you can find a lot of different stuff like that. So when there is a relationship between two variables, they're said to be correlation. Those two things affect each other. They correlate one to another. When the points tend to gather about a line, we say that there's a linear relationship or linear correlation. A scatter plot of the points will indicate that there's a positive correlation or a negative correlation. Okay? But there might be no correlation. So granted, I made these little graphs by hand, and so I'm not saying that I did a great job with them, but can we see a positive correlation in graph 1? It's still kind of scattered, but we could see what looks like kind of like a line of data there, right? Even though there's not an exact line, there appears that we see a positive correlation, meaning it's going up typically from left to right. Does that make sense? Now, some of these points might be above the line, some of these points might be below the line, and some of these points might be on the line, but typically there's a positive correlation. Or over here we see a typical negative correlation. If we drew a line through the average of that data, half of them would be above, half of them would be below, and some of them would be on the line. Does that make sense? And then over here, do we see a positive or negative correlation? It just looks like somebody took a shotgun blast. It's just all over the map, right? Because there's no correlation. There's no rhyme or reason to it at all, okay? All right, so when points are widely scattered, we say that there's little or no correlation. A line that best fits the points in a scatter plot is what we call the line of best fit, and I'm going to show you how to find that. Okay? A line of best fit will have about the same number of points above as below it, and it may or may not go through a couple of points on the graph. Okay? Meaning that if I drew a line through here that looks like it's kind of an average, right? Notice that just in general, I had 3 above. I had what looks like about maybe 3 or 4 below, and I had 1, 2, 3, or 4 on the line, right? Does that make sense? And that's just in general. Okay, if I come over here, right, I'm just going to say it looks like something like that. Okay, I've got 1, 2, 3, 4, 5, 6 above, 1, 2, 3, 4, 5, 6, 7 below, and 1, 2, 3 on. Okay, but I can't tell. There's no way to make a line through that, right? It's going to be typical. Okay, so the strength and direction of a linear correlation is measured by what we call the correlation coefficient, or R value. The values of R can range from -1 to 1. Now, if something is -1 or 1, that means that there's a very strong correlation. The closer it is to either of those two numbers, -1 meaning a negative correlation, looks like a line going down from left to right, and it seems like the data is lining up in a line. The closer it gets to -1, the more points that are actually on the line. Does that make sense? All right. A positive correlation is going to be closer to 1, but it means that the data is going up from left to right, and the closer it gets to 1, the more that data starts to get in line. So it's less scattered, linear. Okay? So both -1 and 1 are lines. Okay? It's not going from scattered to unscattered. Right? Both of those are going from line to line, less scattered. The negative only implies that the data is going down, and a positive implies that the data is going up. Do we understand that? All right, so the further away that my data gets away from -1 and 1, the closer the data gets to what? Let's look at it as a number line. Okay, here's 0, here's 1, here's -1. Okay, so here it's linear, right? Here, it's linear but going down, right? So if my data is moving away from either of those two numbers, what is it beginning to approach? Okay, so the closer I get this way, I'm getting a line of data that is going positive, right? And the closer I get this way, the closer I get to having a line that has a negative line, right? Or a line going downward. But what happens as I go away from 1 or go away from -1? What am I approaching? Less correlation, but what number do I approach? I approach 0. All right? So the closer to 0, either negative or positive that I get, the more scattered my data is. Okay? So linear, positive, linear, negative, and as I get closer to 0, let's say like, and this is where people get confused. Let's say we have the number 0.1. Is that scattered or linear? Right. Okay. What about 0.9? Scattered or linear? Linear. Right? Because 0.9 is closer to 1. 0.1 is closer to 0. What about negative 0.1? Is that scattered or linear? Scattered. What about negative 0.9? Linear, but going down. Okay? Does this make sense? Because students struggle with this. Because the moment that you see 1, students tend to think linear. Right? Because 1 and -1. But with that 0 in front of it, 0.1 is actually a really small number, right? Which is bigger, 0.1 or 0.9? 0.9. 9 is bigger than 1. Okay? So do we understand this so far? Okay. All right. So that's it in terms of that data. I want you to get your graphing calculator out because we're going to have to affect a setting in this so that we can actually get an R value. Your calculator will give you an R value, but only if it knows to give you an R value. Okay? So to do that, we're going to hit second, and we're going to hit 0, which is going to be catalog. Okay? Are we all there? Okay, now we're going to hit our arrow and we're going to hold it until we get to diagnostic on. We're going to go all the way down into the D's. So it's going to start off with A's and we're going to scroll quickly down to the D's. Okay, and you'll find diagnostic off and diagnostic on. We want diagnostic on. Have we found it? Okay, we're going to hit enter. We're going to hit enter again. You may have to hit enter several times. All right, now, the more you use your calculator, sometimes your calculator will mess up and you'll have to reset your calculator. Anytime you have to reset or clear the memory on your calculator, it will automatically turn diagnostic off. Okay, so if you ever want to find an R value and you've had to reset your calculator, you're going to have to hit second, 0, get into catalog, turn diagnostic on. Do we understand that? Okay, so now that's on. Let's pull up some of our data here. All right, so this first question doesn't actually ask you to plug anything in your calculator. It's just a matter of which is the best estimate of the correlation coefficient. Does this line look linear, like really, really linear to you? No. But is it going up typically? I mean, does it seem like it's going up or does it seem like it's going down? Down. All right, so we would be looking at what type of number, positive or negative? Negative. So we would be looking at a negative number. Am I looking at something that's going to be closer to -1 or closer to -0? Closer to 0. All right, so what's closer to 0 but negative? -0.1 or -0.9? -0.1. So this should be my answer here. It has some correlation. The correlation that it has is negative, though. Does that make sense? Okay. All right. We'll clear that out. Let's come down here. All right, this says make a scatter plot of the data, sketch the line of best fit, give the equation of the line. Okay, so for the equation of the line, we're actually going to use information we've already, well, let's see. I'm going to show you something here, okay? We're going to find out something that's maybe more exact than what the answer key is going to give us, okay? All right, does that make sense? Now, you could plot all of this, right? 2, well, it says 2, 4, 6, 8, 10, so it's going by 2s, right? So we'd have 2 and 15, so that would be right there, right? 4 and 11, so about right there. 8, so we skip 6, we go to 8, 8, 16, so about right there. 10 and 21, so about right there. 14, there's 12, 14, it goes clear up to 35. So 14, 35 is right there. 16, so 12, 14, 16, 37. So that's going to be about right in there. 20, 37 is right there. 22, 44 is like up here somewhere, right? All right. Positive or negative correlation? Positive. Is it closer to 0 or closer to 1? Closer to 0, closer to 1. What do you think? Closer to 1, right? So we might say it could be somewhere around like 0.9. It's not exactly a line, right? Okay, so we would say that our correlation coefficient is going to be close to 0.9. All right, we've sketched a line, and if we were to sketch a line of best fit, it would probably look something like that, correct? Okay, just a sketch. Okay, all right, let's do this. Let's pull out our graphing calculators, and we're going to hit stat. Okay, do we see that? See stat in our graphing calculator? Okay, we're going to hit that, and we're going to see where it says edit. We're going to hit enter. And I'm going to delete all the data that I have in here. I'm just going to hit delete several times until all my data is cleared out. If you have anything in there, go ahead and clear it out. I know some kids in Algebra 1 were using calculators, so there might already be some data in there. All right, if you borrowed one from today. All right, is all our data cleared out? All right, so for list 1, we're going to input all our x values. For list 2, we're going to input all our y values. Does that make sense? All right, so I'm going to hit 2, 4, 8, 10, 14, 16, 20, and 22. Okay, now I'm going to go hit right arrow. That's going to take me to list 2. I'm going to put in my y values in the same order. So I have 15, 11, 16, 21, 35, 37, 37, 44. All right, do we have all our data input? Okay, so what I'm going to do now is I'm going to hit stat again. But this time I'm going to hit the right arrow and go over to calc. And what's already highlighted is one variable statistics. So I'm going to go ahead and hit enter. You may have to hit enter several times to get to calculate if you have a newer calculator. And it gives me some information. It tells me what the mean of my data and tells me a bunch of stuff here. But I'm going to hit down. It's going to give me my, my box and whisker plot information. Oh, nope, that's not what I wanted. I want calc, but I don't want one variable statistics. I want linear regression. Number 4. Sorry, I gave you the wrong information. Linear regression number 4. I'm going to hit enter and hit enter again. All right, this puts my equation into slope-intercept form. Notice that it says y equals ax plus b, right? All right, so if I was to write an equation here, I would write y equals, notice that it says a instead of m, right? So I'm substituting m with 1.7, right? 1.7 because it's 1.657, right? That would round up to 1.7. X, and my y-intercept would be b, right? Which in this case is 7, right? Or 7.1. Okay? So basically, if I was to redraw this line, let's use theirs. They're saying that the y-intercept would be about here, and it would be going up 1.7, b going up about 2 over 1, right, is the typical slope of my line. So it may look a little bit more like that than what I drew, okay? So it's a little bit more exact than mine. Notice this. What is the correlation coefficient? Does it list it there for me? What's the R value? R equals 0.95, right? Is that about what we had? We said 0.9, right? So it's actually a little closer to a line than even what we said. All right, let's come down here. What was this, question number 2? Let's look at what their answer. Oh, see how that's pretty, if I actually move this over a little bit. And see how well that lines up? I mean, it's not exact, but it's pretty darn close, right? And notice how our second line is almost exact with what the actual line is. Okay, so our first line was off, but whenever I plugged it in my calculator, I got a different y-intercept, which was more accurate, right? What else do they say? They say that my slope is 3/2, right? What's 3 divided by 2? Is that what, 1.5? All right, I still think ours is more exact at 1.7, okay, instead of what would be 1.5. Okay, but there's a difference of 2/10, which is not a lot. Plus 9, we got plus 7.1. This is where I would say that your graphing calculator is going to be more exact than what the answer key has. Okay, do we understand all the steps that took place there? Okay, what time are we out of here? Is it 36? 36. Okay. All right. Do we feel like we understand this a little bit, though? Okay, at least a little bit. All right, we'll stop it right there.